Good day, everyone. Welcome to our deep dive into modern data management. Today, we will explore how data has evolved from traditional structured formats to a mix of structured, semi-structured, and unstructured types, and how data lakes and lakehouses are transforming the way we handle it all. Plus, we will discuss the roles of data scientists, engineers, and analysts in this new landscape. Let's get started. We have all been working with SQL Server and data warehouses where structured data is the norm. We utilize tools like SSIS and BCP to manage these structured data, transforming and joining the tables before loading the results back into SQL Server, which serves as our data warehouse. From there, we use our BI tools and then generate our reports. These transformations used to be scheduled on an hourly or daily basis depending on our needs. However, today data is no longer just structured. Now, we deal with unstructured and semi-structured data, formats like CSV, Parquet, and more. Let's consider a scenario where we need to design an application for eKYC application, electronic know your customer. The data you will receive will include customer photos, PDF documents such as Aadhaar or social security numbers, and PAN cards. Additionally, we will receive semi-structured data like names, Aadhaar numbers, PAN numbers, date of birth, and addresses, and you will get much more data. This means we are dealing with a mix of structured, semi-structured, and unstructured data. Previously, we only had to manage structured data, but things have changed dramatically, and now the data we receive can be in any format. The source of this data can also vary, ranging from Oracle, Postgre, DB2 to the flat files. Consider any application that generates CSV files. These needs to be integrated into a single source of truth along with other necessary data. In this case, that single source of truth is what we call a data lake. When I first hear the term data lake, it sounded a little complex. People around me discussed it like it was a difficult concept, and I assumed I would have to learn a lot to understand it. But no one told me that at its core, a data lake is just a storage account where you can save any type of file. Because it can store all the required files, it's called a data lake. You can use it to store structured, unstructured, and semi-structured data from sources like SQL, Oracle, DB2, Postgre, Sybase, and flat files. The beauty of data lake is that we have these structured, semi-structured, and unstructured data stored in the data lake. And you can utilize the ETL concepts, like you can use the ADF, you can utilize the data bricks and things like that, and then you can transform these data, and then you can save it in again as a different CSV file, or you can place it in a data warehouse, Azure Synapse, or an Azure SQL database, and in turn you can use some of the BI tools to run the required reports. And also utilizing the data lake, you will be able to use it for data mining, data science, and machine learning as well. So that's the beauty of data lake. Now let's talk about a data lake house. If you store structured, unstructured, and semi-structured data along with other files in a storage account, this is what is called a data lake. Now, when you implement ACID properties, metadata, and governance on top of it, you create what's called a data lake house. So that's very simple as far as the data lake house is concerned. Now you have the same structured, semi-structured, and unstructured data, and you have the data lake. On top of the data lake, once you introduce the metadata and governance, what happens is like it becomes a data lake house. When you bring in some sort of an ACID properties, for example, you save the files onto the storage account, and when you use it as a table, and if you implement ACID properties, that is like you should ensure like not same data is getting updated, and you have some sort of an locking mechanism by implementing the asset properties. If you can follow all these properties, then we get this data lakehouse. Moving on, let's talk about data scientists, data engineer, and data analysts. Data scientists use statistics and machine learning models to make predictions and answer key business questions. The required skills include mathematical formulae, programming, and statistics. So their go-to technology would be SQL, Python, R, and cloud. Moving on, if we talk about the data engineers, they build and optimize the systems that enable data scientists and analysts to do their work. Their skills include programming, big data, and cloud technologies. Their go-to technology would be SQL, Python, cloud and distributed computing. Data analysts, on the other hand, use the systems developed by data engineers to deliver value by communicating results that drive business decisions. The required skills include communication and business knowledge. At least for me, I fall into the category of data engineer where I support the existing setup. I leave it to the data scientists to design models and write the necessary programs. My role is to support these models with my expertise in SQL, cloud technologies, and distributed computing, and some knowledge, maybe limited knowledge on Python and other programming languages. That's it for this video. Thanks for watching. Have a great day. Jai Hind.